Okay, before we start going through these notes, you want to make sure that you've got some other tabs available in your browser. One is a uh, notebook in CoCalc where you're keeping notes of what you did today. The second one is uh, the book Python for Everybody, and it's open to chapter 2. That's the chapter we're going through. And then finally, there's these notes. Okay, so let's get started. Just some junk there. So this is Notes on Python for Everybody, Chapter 2. And I just note here that I want to make sure that you have Python running to experiment, as well as the book, and there's a Jupyter Notebook to run code and make your own notes. Values and types. Read the text section, then proceed. Okay, at this point you want to look down to the lower left corner of your screen and hit the two vertical bars, stop, go over and read the text section. Okay? Okay. There's the text section. Now, back to the notes. What are the three types described in this chapter, and how are they distinguished? Use the type function to examine a constant value of each type. Again, this is the point where you have to stop the video, go to your notebook, and do what you've been asked to do. And I'll wait for you. No, I'm not going to wait for you. I'm just going to assume that now because you've started the video again, you've done what you're supposed to do. And let's see what it was you were supposed to do. The three types are str, and I'll usually just say string, or I'll write string instead of str, int, an integer, float. Okay? String, integer, and float. How do you tell what they are? Well, a string is enclosed in quotes. Could be single quotes or double quotes. Int contains numbers, but no decimal point. It must not contain commas. A float contains numbers and a decimal point. Check a string value for type. Stop the video and do that. Okay. Back to the video. I check the type of the quoted string 245, and it says it's of class string. I check the type of the quoted string hello Julius, and it is of class string. It's a string because it's enclosed in quotes. Now, check an integer value for type. Pause the video while you're doing that. And after you get through doing that, restart the video. Okay, you've restarted. So I check the type of 124, no quotes, no decimal point, and it says class int. I check the type of minus 756, and it says class int. It can have a minus sign, but it can't have quote marks or decimal points. What happens if an integer begins with 0? Okay, this is something that Severance didn't cover in Python for Everybody, but check this out. See what happens if you say something like 09. Again, pause the video while you experiment. Okay, you've restarted the video. In CoCalc, you should have tried to get the type of 09. I can't do it here because if I do it here, it will provoke an error, and that would kill my slideshow. Okay. Commas. Normally when we write numbers with lots of zeros, we have to put commas in there so that you don't go crazy trying to count the number of zeros. When you see two groups of 3, you know it's 6. And the commas made that possible. Without the commas, that's a really tough thing to read. What happens if you do that in Python? Try the following. If I let it run here, it stops the show. Note that Python does allow you to break up integers with underscore instead of commas. So 1 underscore 000 underscore 000 works. That is a valid integer. Check a float value for type 12.45. There are numbers and there's a decimal point. So that says class float, type of -1.5. That's of class float. Type of 0.32. That's of type float. Type of 0.32. That's of class float. So a leading zero is okay with a float, but it's not okay with an int. We'll see later on why that is. What's the issue with having a leading zero? Doesn't seem like it should be a big issue, but it is. Section 2.2, variables. Read section 2.2 in the text. And to give you something specific to do, copy the definitions of variable and assignment from the text to your notebook. Okay, you're back. Started the video again. Use assignment statements to assign values of each of our current types to named variables. Use any names you want. Then use the type function to investigate each. Okay, stop the video and do that. Okay, you're back having restarted the video. So Tom is 1, Dick is 1.5, and Harry is quote 2 quote. What's the type of Tom? It's an int. What is the type of Dick? Dick is a float. What is the type of Harry? Harry is a string. And what is the type of Tom again? Oh, it's not quite the same. Notice that it's spelled with a lowercase t instead of an uppercase t. And of course, I can't do that, and that fails. Why does that fail? Well, Python is case sensitive. That's something to remember from the very beginning. Capital TOM and lowercase TOM are completely different, and lowercase TOM has never been defined, so that'll blow up. Changing the type. This is something I had to throw in here because it's important at this point. Suppose you need an int value, but the data is in a string. The function int will accept a string and return an int if the string is a valid int. So, for instance, I created a string, which is the quoted string 25, and then I print the type of a string, and it's a string. And I print the value of a string, and I see the 25. I print a blank space. Then an int is int of a underscore string. Print the type of an int. It's an int, and it has the value 25. They look the same here and here, but this one is the value of a string. This one is the value of an int. And if you need an int, you really need an int. You can't get by with a string. So here's a good question. What happens if the string is not a valid integer? So here I have a string is 25. Print type of a string. And I hope you paused the video. I forgot to tell you to pause the video before you did this. Well, okay, pause the video now. And try to convert that thing to an int. Try to get an int out of that string. It should be pretty obvious. Doesn't work. Okay. A legal Python variable name contains letters, numbers, and underscores. Must not begin with a number. It must not be one of the reserved words listed in the section. In the exercise in CoCalc, try several different ways to break these and observe how Python reacts. And pause the video, go over there to CoCalc, play around for a few minutes, and see what happens when you break the rules. Here's some obvious bad names. My.book, what's wrong, contains a period. My dash book, that's not an underscore, it's a dash or a minus sign. Can't contains an apostrophe or a single quote. Joe at stmartin.edu contains an at. 23 skidoo begins with a number. Lambda is a reserved word. You probably wouldn't have guessed that. Yield is also a reserved word. So see what you get out of CoCalc when you try to use those things. Section 2.4, statements. Read the section and write a command statement. Pause the video while you do that. Okay, you've restarted the video. Here's a typical command, print 3.4, and you printed 3.4. Now, write an assignment statement and pause the video while you do that. Okay, you're back watching the video, so you must have written an assignment statement. And there's an assignment statement, x equal 3.4. There's a name on the left, then the equals symbol, then some kind of a value on the right. Note that an assignment does not cause Python to display the result. Operators and operands. Read this section, and the usual binary operators are mostly as in Excel, with the exception of exponentiation. In Excel, you can say caret. In Python, exponentiation is represented by a pair of asterisks. And there's a special version of division for integers. Exercise, compute 4 divided by 3 and 4/3. So pause the video while you do that. Okay, the video is going again. You must have done the little exercise and restarted the video. And I did something a little bit different. Instead of 4 divided by 3 and 4/3, I did 5 divided by 2 and 5/2. Oh well, you get the idea. When you do 5 divided by 2, 5/2, that you get the floating point result 2.5. If you take 5/2, you get the integer result. 2 goes into 5 2 times. And of course, remember that that's not the entire answer correctly in grade school, is it? You also have to talk about the remainder. 2.6, expressions. Read the definition of expression in this section and copy it to your notebook. This section makes a distinction between the use of a Python expression with the interpreter as opposed to within a script. How does an expression work in a cell in CoCalc? Well, try that. Stop the video while you try that, and go ahead to the next section after you've completed your work. Okay, you're back watching the video. Order of operations. Read the section and predict the values of the following expressions. And again, stop the video while you play with these things. See if you can see what they're going to do. But please stop the video. This is not a time to just watch and listen. This is a time to do things. Okay, you're back watching the video, so I assume you've done all these things. And let's look at the results. 2 plus 3 times 5. The first thing we got done was the multiplication, because that's first in the order of operations. So you multiplied 3 times 5, you got 15. Then you added the 2, you got 17. In the next one, 2 plus 3 times 5, you change the order of operations by putting parentheses here, because anything in parentheses is done first. 2 plus 3 is 5, multiplied by 5 is 25. Here, 2/3/5, it depends on what you do first, this slash or this slash. If you don't have any parentheses in here, you get 0.13 blah, 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 blah. But if you put the parentheses in here so that you do the second slash first, what you get is quite different. The normal rule is that if you have the same level of operation, you go from left to right. Okay, the next one, 2 plus 3/5, or 2 times 3/5. 2 times 3 is 6, divided by 5 is 1.2. What would happen if you put parentheses here? Or rather, if you put parentheses here? Try that. And here's probably one that most people have trouble with. -2 squared. A lot of people will say that this is plus 4 because you're squaring the -2. And the way mathematicians and Python see this, the rule is that anytime you see a minus sign written in front of something, it is equivalent to multiplying by -1. So read that as -1 times 2, star star 2. And then you can see that there is an exponentiation which has to get done first. So you get the 2 squared. Then you multiply by the -1. That's an extremely confusing point. Exercise of the following 3 Python expressions, which 2 are equal? Well, the first one has no parentheses. The second one puts the parentheses on the left. The third one puts the parentheses on the right. You would think, if the general rule is that you always work from left to right, that the first and second would give you the same result and the third would give you something different. Okay, well, try those in CoCalc. Pause the video before you try it in CoCalc, then come back with the answer. Okay, I assume that you have done your work in CoCalc and you've restarted the video, so let's look. So there's no parens, there's left parens. It may shock you that this and this are not the same, because why didn't it go from left to right? Right parens, it went from right to left, this and this. So no parentheses and and the parentheses on the right give you the same result. So exponentiation is a special case. It doesn't go from left to right, it goes from right to left. What do you make of that? Well, you're liable to forget these rules. You're liable to have a hard time remembering them all. My suggestion is that you always take command of the situation by inserting parentheses. That way you know what gets done first. The modulus operator, or the remainder operator. Read the section, 2.8, then do the following computations, and check your answers in CoCalc. These are easy to do by hand. Pause the video, do the work in CoCalc, and come back, restart the video. Okay, I assume you've restarted the video after doing your work. So 5 divided by 2 is 1, or 5 remainder 2 is 1. 5 modulus 2 is 1. The remainder upon dividing 5 by 2 is 1. That's the better way to say it. The remainder upon dividing 13 by 5 is 3. The remainder upon dividing 4 by 2 is nothing because it went in evenly. The remainder upon dividing 0 by 2 is 0. And the remainder upon dividing minus 5 by 2 is positive 1. Remainders are always positive. String operators. Plus and star are meaningful for strings. The symbol plus denotes concatenation, or placing together, and the symbol star between an integer and a string repeats the string the specified number of times. So let's look at the following examples. If you concatenate hello and Joe, you get hello Joe, and there was no blank space included. Here is hello plus comma blank space plus Joe, and that gets you the comma and the blank space. Here's multiplication. 3 times hello plus Joe gets you hello Joe, hello Joe, hello Joe. And here's a little combination of concatenation and multiplication. String A blank plus 2 times Merry blank plus Christmas plus to you is a Merry, Merry Christmas to you. A couple months yet. The input function. The function prints its argument on a console and then returns whatever is typed. Typo there. I should have it typed. I'll try to fix that later. So the function always returns a string. Experiment with the example provided in Python for everybody using CoCalc. And then I have to ask a question. What happens if the user inputs a float? Try that in CoCalc. Take the example in Python for everybody and do it in CoCalc. And then let the user input a floating point result. The answer is, of course, that it will fail. See the notes on input above. How can you get from a string containing a float to a valid integer? How do you do that? Certainly, if you had 25 point and you wanted to convert it to an integer, it should be possible. Well, here's the way you do it. A string is quote 25 quote. That's a string. And int is int of float of a string. And that'll work. You have to go through this intermediate step, convert the string to a float, and then use int to convert the float to an int. That worked. If you try to go directly to an int, it fails. Comments. You'll be told many times that you really do need to put comments in your code. I go even beyond that, and I like to get a lot more written than just plain comments. That's why I prefer Jupyter Notebooks. Jupyter Notebooks encourage you to really write extensively about what you're doing in markdown cells. In a Jupyter Notebook, the things that you write, the text that you write, has equal status with the code that you write. Code happens in code cells, markdown happens in markdown cells, but the comments, which are far more extensive in a Jupyter Notebook than they will be in a normal coding environment, will be much more extensive. Choosing mnemonic variable names. Yes, that's important. Read the example with hours, rate, and pay in Python for everybody is very instructive. Using mnemonic variable names is good. Another point that I want to emphasize is the conventions that you use to create multi-word variable names. take, for instance, date of birth. There are different ways that you could write that. There's begin with a lowercase and then use an uppercase letter for each separate word. Or you could begin with an uppercase and again, every following word begins with an uppercase. Or date _of birth, all lowercase. So that's the one that I want you to follow consistently for naming variables. And I want you to follow that consistently, at least for the names of variables. The names of other things will follow different rules. All lowercase, words separated by underscores. And I'll point you to a reading on PEP 8, Python Enhancement Proposal number 8. It's here. It's not PEP 8 itself. It's a very readable version, and you can get a lot of style guide information out of that. Well, that's the end. I hope you spend some time reading this. And also, this is probably about a 20-minute video on Jupyter Notebooks, and it'll give you a good example of the really extensive things that you can do with a Jupyter Notebook. So this last slide has an awful lot of extra reading to do. And I think that's about the end.